A crab was farming, 2,000 meters underwater, on its own arms. The 7th of March, 2005, the Pacific Antarctic Ridge, DSV Alvin descended through water so cold and dark, it registered as nothing on every instrument except depth. At 2,228 meters, the floodlights caught something pale, white, completely still against the black sea floor. The operators had never seen anything like it. The creature was the size of a dinner plate, both claws stretched forward, dense with bristles. Not sparse, not scattered, but layered and architectural, each filament catching the submersible's light like frost on wire. Enrique McPherson, the taxonomist who would later formally describe it, had spent decades cataloging crustaceans. Nothing in his records came close. It had no family, literally none. McPherson, William Jones of Mbari, and Michel Segonzac of Ifrema co-authored its formal description in 2006, published in Zoosistema. They named it Kiwa hirsuta and built an entirely new family around it, Kiwidae, because nothing else existed to classify it with. The eyes were blank, no pigment, no function, permanently, irreversibly blind. McPherson's paper noted that the carapace and appendages are densely covered with setae, which are particularly abundant on the chelipeds. Clinical language, careful language. But it left the central question completely open. Why? Why would a crab at 2,228 meters need that much bristle? Why on the claws specifically? And why, on the ROV footage, was it moving them like that? Slow, deliberate, rhythmic sweeps through the water above the sea floor. Nobody had an answer in 2005. Nobody had one in 2006. The footage existed. The behavior was recorded. The explanation was not there yet. 6 years later, a paper changed everything. Andrew Thurber at Oregon State University published findings in PLOS One that finally made the footage make sense, in a way that nobody watching in 2005 could have predicted. By the end of this video, that behavior on Alvin's recording will mean something completely different than it did the day they filmed it. The paper is dated 2011. The behavior it describes has no parallel anywhere else in the crustacean world. The simplest explanation came first. It almost always does. When McPherson, Jones, and Segonzac formally described Kiwa hirsuta in Zoosistema in 2006, the bacteria coating those bristled claws were noted but treated as background noise. Deep sea surfaces accumulate microbial life. That is just what happens down there. A rock, a pipe, a crab claw, all of them collect bacteria at 2,000 meters. Nothing unusual. Move on. And for a moment, that held. Passive colonization is real. Leave any surface in bacterially dense water long enough and organisms will attach. Tube worms get it. Barnacles get it. The deep sea is not clean. It is thick with microbial life drifting on slow currents, settling wherever it lands. The bacteria on Kiwa's claws could simply be hitchhikers, opportunists, nothing the crab chose or controlled. But the distribution was wrong. Shana Gaffredi at Occidental College analyzed the bacterial communities on Yeti crab setae in 2008. What she found was not the random patchwork you see on passive surfaces, uneven, mixed species settling wherever the current dropped it. The bacteria on Kiwa's claws were dense, uniform, consistent from bristle base to bristle tip, specific species. Predominantly epsilon proteobacteria, sulfur-oxidizing chemolithotrophs that thrive near hydrothermal vents. Hitchhikers do not line up in rows. Then there was the anatomy itself. McPherson's own 2006 description noted it directly. The carapace and appendages are densely covered with setae, which are particularly abundant on the chelipeds. The claws carried the heaviest bristle load. Not the legs, not the back, the arms, the harvesting surfaces. Passive colonization does not explain structural preference. The bacteria were the right species in the right place, in unnaturally even distribution. 3 things passive colonization cannot produce simultaneously. The hitchhiker theory was not wrong. It was just incomplete in exactly the places that mattered. Which raised the real question: if the bacteria were not just settling there on their own, what was Kiwa hirsuta actually doing to put them there? Here is what Thurber actually documented. In 2011, Andrew Thurber at Oregon State University published a study in PLOS One on Kiwa pura vida, a close relative found at methane seeps off Costa Rica. The paper described something the original discovery footage had hinted at but never explained. The crab was not just carrying bacteria, it was running an operation. K. paravida was observed waving its claws in the water above bacterial mats, apparently to cultivate bacteria on its setae. That is a direct quote from the paper, a crustacean waving its claws to seed a crop. The mechanism works in 3 stages. First, the claw waving is not random. The motion is rhythmic, consistent, and directional. It draws hydrogen sulfide-rich water across the bristle surface, feeding the sulfur-oxidizing bacteria that live there. Second, the bacteria multiply. Third, the crab uses its mouthparts to scrape them off and eat them. Thurber confirmed it. The crab was observed to scrape bacteria off the setae with its mouthparts. Aerate, harvest, replant, repeat. This stopped researchers cold. Not one behavior. 3. Coordinated. Remember that 2005 footage from the Alvin dive, the claw motion nobody could explain at the time? That was stage 1. The crab was aerating its field. The scientists watching the playback saw grooming. They were watching irrigation. The bristle architecture, the grooming reflex, the waving behavior, the positioning near vent flow. None of these work without the others. Remove one, and the system collapses. Evolution produced not a trait, but a complete agricultural package, which forces a harder question than any the discovery raised. Farming, as we define it, requires deliberate cultivation across a cycle. Kiwa does that. Blind, cold, 2,000 meters down, with no sun and no soil. If farming is defined by the loop of seed, tend, harvest, then a crab that has been running that loop in total darkness, on its own arms, since before any human planted anything, qualifies. That is the receipt the 2005 footage was writing. Thurber's 2011 paper is what it says. If you found this fascinating, subscribe. We investigate strange, real creatures like this every single day.